In this video, we are going to discuss the quadratic formula shown here, and we are going to look at the discriminant as well, and discuss what these two things do for you. Okay, so the entire quadratic formula gives you the zeros of any quadratic function, no matter what function it is, whether it's factorable or not factorable. We talked about factor by grouping already in this unit, and you can factor some quadratic functions to get the zeros, but you can't factor all of them. This case here, this quadratic formula you can use for any quadratic function. Okay, the part that's inside the radical here, b squared minus 4ac, is called the discriminant. We're going to talk more about that and what it does for us within a problem. So finding zeros, all you need to do is find a, b, and c, and then plug those numbers into the quadratic formula in order to find the zeros. So I'm going to look at number 4 here. We have f of x equals 3x squared minus 4x minus 8. So if our function is equal to 0, we can find the zeros by using this formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. In order to plug these numbers in, we identify what a, b, and c are. A, b, and c are constants or coefficients of the standard form which this is in. So a is always in front of the x squared term, that's 3. B is in front of the x term, it's negative 4. And c is negative 8, the constant term at the end. So all you need to do is replace a, b, and c with 3, negative 4, and 8. Calculate, and your zeros will be given. So it's going to be x equals negative 4. The first negative is for negative b, and b is negative 4, so you do need both there. That will eventually simplify to a positive 4. Plus or minus the square root of b squared. You do need to put this b value in parentheses. You don't want a negative square when you should get a positive. Minus 4 times a is 3, times c, which is negative 8. And this is all over 2 times a. A is, in this case, 3. So step 1 is to identify a, b, and c. Step 2 is to plug in a, b, and c into the quadratic formula. And then step 3 is just to evaluate. So negative 4 is a positive 4, plus or minus. Now this part on the inside called the discriminant, go ahead and evaluate that all at once you can in the calculator. And when you do that, you get 112. And 2 times 3 is 6 on the denominator. I'm going to highlight the discriminant to show you what turned into what. Now, this plus or minus here in the middle, that is showing you that there's 2 possible zeros here. So you need to split it up into 2 different zeros. So over here, I'll write it. One's going to be 4 plus the square root of 112 over 6. And the other one's going to be 4 minus the square root of 112. That's what the plus or minus is for. It's telling there's 2 situations, one where there's addition, one where there's subtraction. So these are the exact answers. If you wanted the rounded answers, you just calculate this. So 4 plus square root of 112 over 6 ends up being approximately 2.43. And 4 minus the square root of 112 over 6 is going to be approximately negative 1.10. If you're using the calculator for the evaluation of these 2 zeros, you need to put the entire numerator in parentheses or make it a separate step in the calculator, because you need to divide both terms by 6, not just one or the other. So we use the quadratic formula to find the zeros. We have found the zeros. This problem is complete. Now, you're not always going to get 2 real zeros. Sometimes you'll get less. You can have a possibility of getting 1 real zero or no real zeros. And we'll talk more about that in the next couple of examples. Number 7 on the notes, we have 3x squared minus 10x plus 9. So Our equation is written like this. Identify A, B, and C. A is 3, B is negative 10, C is 9. So plugging these into the quadratic formula, it's going to be negative B, so it's negative 10, plus or minus the square root of negative 10 squared minus 4 times A, which is 3, times C, which is 9. That's all the numerator there. Divided by 2 times A, which is 2 times 3. Alright, evaluate. X equals negative 10 is a positive 10, plus or minus the square root. The discriminant turns out to be negative 8 all over 6. There is an issue. The discriminant is negative. You cannot square root a negative number and get a real number. You get an imaginary number. So therefore, when you have the discriminant that is negative, you're going to say no real zeros, because there are no real zeros. There are imaginary zeros in this case, but there are none that are real, none that appear on the graph. This is where the parabola is pointing up, and it's above the x-axis where it doesn't cross. That gap right there. Okay, when there's that gap where it doesn't cross the x-axis, there are no zeros there. So your discriminant is negative. There are no zeros. All right. Now let's say the problem just says find the number of real zeros for this quadratic. If it just says find the number of real zeros, you don't have to do the entire quadratic formula. You just need to do the discriminant portion. So here, the 3 possible situations are: you can have 2 real zeros, where the parabola crosses the x-axis twice. That's when the discriminant is positive. Situation 2, you could have 1 real zero, where it kind of just skims the edge of it or intersects it once. That's when the discriminant is 0. The last situation is the one we just had with our quadratic formula example. That gap in between where there are no real zeros or no x-intercepts, that's when your discriminant is negative. We had that negative 8 for our discriminant, therefore there are no real zeros. That's what this picture is telling you right here. So if it just asks you how many real zeros a quadratic function has, you're just going to do the discriminant portion. You are just going to do b squared minus 4ac, and you're going to determine if it's positive, if it's negative, or if it's 0. If it's positive, it has 2 real zeros. If it's negative, it has no real zeros. If it's 0, it has 1 real zero. That's what the pictures above were saying. So this one here, b squared minus 4ac, a is 3, b is negative 6, and c is 3. So b squared minus 4ac, the parts in the radical, you're going to do negative 6 in parentheses squared. It's very important you put those in parentheses, like I said before. Minus 4 times a, which is 3, times c, which is 3 as well. So we have 36 minus 4 times 3 times 3. That's going to be 36 as well. 36 minus 36 is 0. Your discriminant is 0. Therefore, there are just 1 real zero. So your discriminant is 0. There's 1 real zero. If we were to do this work and we got a positive discriminant, there would be 2 real zeros. If you do this work and you get a negative number, there are no real zeros. Those are your only 3 options. It doesn't necessarily matter what the number is, if it's positive or negative, as long as it is positive or negative. It could be very large, it could be very small, depending on the problem, just as long as it's positive, negative, or 0 in this case. So that's how you find the number of real zeros using the discriminant. We talked earlier about finding the actual zeros using the quadratic formula. So it depends on the question that's being asked of you. Are they asking you to find the zeros, the particular ones, or just find the number of real zeros? You can use the quadratic formula for the first and then use the discriminant just for the second.